Hi everyone, this is Adam Hops with the National Operations Center of Excellence. We're going to go ahead and get started today. Thank you to everyone who is able to join us. Just a reminder, all webinars at NOCO are recorded and available for free on our YouTube channel to be shared with colleagues. I put the previous the link to find previous webinars there in the chat box. Upcoming webinars are also available on the calendar, including the September Road Weather Spotlight. So be sure to register for that. There again using the link in the chat box. Two ways to get a hold of presenters during today's webinar. First is via the chat box I just mentioned. That's for if you have any technical difficulties or to find links or share any information. We will be holding a conversation after the presentations. To participate in that conversation, please use the Q&A box. So two different boxes, the chat box to get a hold of us for anything that you need, the Q&A box to participate in the conversation with presenters. So you can find those on your screen that are there. A big thank you to Tony Coventry and the team at the Road Weather Management at FHWA for allowing us to host this webinar series each month. The conversations have been extremely valuable since May when the series started. If you've missed out on those, be sure to check them out on the YouTube channel, the previous webinars, and of course to keep joining us every month. Tony, thank you again, and I'll turn it over to you.
Okay, thanks, Adam. You can go ahead and go to the first slide. I want to first welcome everybody. Good morning if you're on the West Coast, and good afternoon if you're on the East Coast. This is as Adam said, the fourth in the series of spotlight webinars that the Federal Highway Management Program's Road Weather Management Program has actually been putting on monthly to sort of highlight and put a spotlight on different subjects and areas, different challenges that we're all experiencing in the road weather community. So this today's conversation is going to be more about connected and automated vehicles and how they can be part of the solution for our road weather management operations. As Adam said, this is the fourth one. We're going to keep doing them for the next couple of months. So you can always go to the NOCO website and look at the past ones if you want, as well as look at what the subjects are going to be going on in the future. So go ahead with the next slide then. So today, as I mentioned, we're going to discuss connectivity and automation in road weather management and operations. And we have a really good lineup of speakers. Tyler Weldon from Colorado DOT and Peter Jager from Utah DOT and Dan Rowe from Minnesota DOT are with us today. Next slide. So just an overview of what our plan is on. The first thing was to welcome you all. And again, thank you very much for taking the time out of your day to listen to the speakers today and participate in the discussion that we're going to have at the end about some of these technologies, perhaps other technologies that you're interested in, and how they relate to road weather management. We're going to start off, and I'm going to give an overview of some of the things that we're working on with respect to CAV. CAV being connected in automated vehicles, the new acronym. As many of you know, when we first started this 20 years ago, I can't think of what it was. It was called IntelliDrive when we first started doing that. And we've come all the way to use the acronym CAV to sort of encapsulate the concept of connected vehicle, the data we get from them, and automated vehicles and how they work on our roads today. So the presentations we're going to give today are, again, as I mentioned, from Utah on the connected vehicle snowplow deployment, and then Minnesota's connected vehicle traveler alert system. So that's using real-time data to talk to people, and then Colorado's autonomous truck mounted attenuator. And if you've ever driven by that, it's kind of an interesting thing to drive by an attenuator truck with nobody in it, but it's moving along following another truck. So these are some really good presentations. And then of course, at the end, we're going to have a discussion where you can ask questions and they'll answer those questions real time, and we'll try to get a discussion going on some of these technologies. So if you have questions about these subjects, while they're discussing, please put it, as Adam said, into the question and answer box, and we'll make sure we feed those to the panel as we get going. And then finally, we'll have a couple announcements at the end about the next couple of webinars coming up. Next slide. So before we get going, I wanted to put this poll out there. So if you wouldn't mind participating and answering a couple of questions, they're all on the one screen there. So first, give us an idea if there's anything that you guys are working on or planning on implementing in terms of infrastructure changes to your facilities from an operational perspective? Are you going to put electric vehicles in? Do you need to put charging stations? Any other kind of things that you're doing to automate your own vehicles? And then, of course, the second question is, are you going to is your agency part of any active or planned research efforts? So a lot of us have put together different strategic plans, but those might have changed now with the advent of connected and automated vehicles. So do we need to start looking at some of those planning efforts and research projects and sort of our strategic things that we do to include those kinds of things that are in there? And then the third question, other than funding, what do you believe is the most critical for connected and automated vehicle technologies to be successful in our agency maintenance vehicles? So if you wouldn't mind, go ahead and put a couple of answers in there. I'll give a few minutes to you to kind of answer those questions. All right, do we have the results back, Adam? Anything? Okay, so again, appreciate you answering the questions. Obviously, charging stations for electric vehicles is a big answer, and that's kind of understandable, especially with the new agenda of the present administration, where electric vehicles are an important part of what we're doing, not just for the public, but even for the agencies that we all are part of, in making sure that we're using some of that technology too. And then sensors and communication technologies, I could see that being pretty big too. We already do that in a lot of ways. A lot of you are familiar with the IMO program in terms of bringing back mobile data from our fleets. So that continues to be a popular one. V2I, that's not quite up there yet. We're still working on that, right? And then roadside units. And by the way, if you answered other and there was something else that you wanted to put in there, please, put that in the chat or in the question and answer, and it might be something we can discuss when we get to the panel later, a little bit later. And then the second one, is your agency part of any active planned research efforts? I guess 69% strategic planning efforts. That's good that we're doing that, because that's going to be an issue, I think. And then state-funded research projects. Of course, everybody wants to know how these things are all going to work. So, and then finally, the third question. Regarding communications, yeah, the 5.91 was 37%, and additional research pilots are 47%. Probably the highest response. In other words, more research pilots to demonstrate, and we're going to talk a little bit about some of those today. So I'm glad that that's important, because that's a big part of our discussion today. So thanks for showing that, Adam. If you want to go to the next slide. So just to get the ball rolling, I wanted to kind of sort of highlight, within the federal highway, some of the programs, and this was done during our program review. We asked the questions of different agencies in terms of their interest in connected and automated vehicles. And obviously the key, interest was increasing for mobile data of cab application developments. And some of our research has kind of stemmed around that, like adaptive route optimization. Increased inclusion of connectivity and automated driving capabilities for the strategic planning documents. And that's one of the poll questions too. So we heard that from you guys, that's something that you need to have a better handle over. How do we address that in part of our strategic planning documents? And then there's also a strong interest by agencies to work with external organizations. And I think this is kind of some of those things where we're dealing with doing AVL and some of the sensors that connect to AVL, and how do those companies that provide those services, we work better with them. So that's part of that. We're kind of aware of that. And then real-time fleet data, that comes back to the AVL. Obviously, that's a hot topic of making sure we're getting the data back real time. Increase the agency deployment of safety warning systems. So there's a lot of projects that are out there, to name a few, up in Michigan, things like curve warning systems, real-time curve warning systems, things like dynamic and variable speed limit systems that take in real-time weather data and adjust the messaging to customers. So we're starting to do a lot more research on that too. But these are the areas that we got from you that we're going to start using to sort of, I guess, guide the direction of what kinds of research we're doing at the Federal Highway Administration when it comes to cab. So next slide, please. So within the road weather management program, I just wanted to kind of highlight a couple of the research projects, given all of that sort of feedback we got from you. The connected vehicle pilot deployment project in Wyoming was one of the first we did, and that's been around several years, right? The CV pilot. And that was one of the first I think we did to sort of show how connected vehicles could work in our operations. The roadway automated driving systems. And by the way, some of these research weren't necessarily part of the road weather management programs research, but they were associated with us. So we had some input into what they were doing. So automated driving systems for automated fleet applications. The two blue ones in the middle, ARO, this is the most recent research we've done, adaptive route optimization. And this takes real-time connected vehicles, snow plows, and tries to develop solutions that allow those routes to be adapted dynamically real-time to be more efficient. And that requires that sort of connectivity as part of it as well. And it's one of the upcoming webinars. So if you're interested in learning more about that, it's going to be coming up in the next couple of months. And then IMRCP, which I've been talking about to you guys for a long time. And this is the modeling of taking weather data, traffic data, and sort of predicting what the impact of traffic and transportation systems are going to be using multiple sets of data. So that we're also going to have a spotlight webinar on where we are with that research. And most of you know we're almost near the end of our phase 4 and going to be starting phase 5 sometimes in the next year. And then automated vehicles and adverse weather. And I've provided some of this results. This was completed last year, and I've been giving out some of the results of this at different organizations that I know many of you have gone to and probably seen those results. We even delivered it to PIARC internationally. So that was a big research project that we were part of that sort of looked at the impact of weather on automated vehicles. And then, of course, the Everyday Counts initiative, where we're trying to deploy some of these connected and automated solutions out to you guys the easiest way we can. So the next slide, finally, I just wanted to kind of give an overview of that AVAW, some of those results. So this was a joint effort between the Road Weather Management Program, the Turner Fairbanks Research Center, and ITS JPO. So those organizations came together and basically researched and tested what the impact of weather conditions on an automated vehicle were going to be at different levels of automation, level 2, level 3. And I'm not going to go into the details. There's several different things out there. We'll be giving some of those details at different organizational meetings in the future. But the summary I'll let you know is that from that testing, it's clear, and I think most of you know that it's clear that there's a lot of work that still needs to be done with respect to how weather is going to impact automated vehicles. Some of those didn't exactly work the way they were supposed to at that time. So there's certainly some more research here that's going to be needed. And with that, I just try to give an overview of some of the things we're doing here. And I'm going to go to the next slide and hand it off to Peter to give a discussion about the connected vehicle systems and snowplows at Utah DOT. Peter?
Thank you, Tony. Peter Jager I'm an engineer. To talk today a little bit about our snowplow connected deployment.
Hey, Peter, your audio is a little bit skippy. Maybe a little closer, a little further from the mic.
How's that? Any better?
That's better. Thank you.
Great, thanks. Let's go ahead and launch the next slide and give you a little background here. Our connected vehicle deployments. In 2017, we started with a transit system priority. We had a willing partner in our transit agency let us put some devices on their buses and see if we could get the schedule more reliable. We worked on a transit signal priority, giving the early green or extended green lights buses when they were more than 5 minutes late, trying to get them on schedule and stay on schedule. Using the same DSRC technology on that same corridor, we put onboard units on snowplows to give them signal preemption. They would get a green automatically every time. So you can see on the map 2017, click through the other blue dots on the map are locations where we added more roadside units from our snowplow routes, about 5 corridors around the Salt Lake Valley. And during this time, 2018, there was a BRT route being constructed further south in Provo. You see at the bottom of the map, Provo-Orem area. So already having the roadside units in place, we were able to equip snowplows there and expand the system down there. So the snowplow system went live in 2019 up north, and a little bit later in late 2019, the following winter in the south. So we had to click through the slides, 131 roadside units and 86 total onboard units between the buses and the plows. And here's a look at the roadside hardware. You see at the top left there, roadside unit, that basically an antenna mounted on the traffic signal mast arm. And so with the antenna there, it's connected to the signal cabinet down below by a Cat6 cable and into a Linux-based signal control module inside the traffic signal cabinet. And from there, it connects to our statewide traffic fiber optic network, back to the traffic operations center and the signal control software. And over on the right, you can see the onboard units. The buses had a large server rack. They're in the top of the slide. But the onboard unit itself is pretty small, so we were able to mount it easily in the snowplows, either under the seat or under the dashboard or behind the passenger seat. You can see some snowplow controls there, the spreader and the plow equipment. We programmed the system to work connected through the spreader. We had some technical issues connecting it to the plow up or down, so the signal preemption would only work when the plow was actively spreading salt or brine. That way the system is only used when they're actually actively plowing snow. So basic look at the snowplow operations here. When the plow comes into range of the DSRC, the plow is continuously broadcasting the basic safety message, or the BSM. It's also receiving the SPAT and MAP data, the signal phasing and timing. So as it comes into range of the traffic signal of the roadside unit, the GPS reports the plow location, and the software called MITS determines the plow location in the lane and the distance to the signal. It sends a preemption request to the roadside unit, and the preemption request goes to the signal controller. It can process that request. It can't send a message back to the snowplow telling it whether it's going to get a green light or not, based on limitation. It just confirms that the message is received. So the onboard unit on the plow knows the message is received, but the driver is instructed. The driver has no interaction with the system. It's all automated in the background. So the driver is instructed to follow the traffic signal display that they see, follow the red, yellow, or green. So it all operates automated in the background. They don't get any kind of a magic button or remote control of the traffic signals. So our initial project here in 2019, 5 corridors, 55 intersections here. The red dots were the initial transit corridor on Redwood Road along the west side of the valley, and the blue dots were the additional intersections we equipped for snowplows. They went live in March of 2019. Right at the end of winter, we caught one of the last big snowstorm and a little bit of another storm, so at least got to test it that year. And phase 2 went live, was finished. Only required 5 more traffic signals to be equipped and the 10 snowplows for the maintenance area in the Provo-Orem area. So both projects were ready for the following winter of 2019 and 2020. Here's a look at the user interface. This is an online interface built by our local contractor to help us monitor and troubleshoot the system. The yellow dots you see on the screen is the plow moving up and down the corridor, or a bus in the case of tracking buses. And they leave behind cookies on the map, the blue and orange dots, so you can track it. If snowplow is reporting, not getting any preemptions, we can go watch it live on the screen here and see if it's tracking, if it's sending and receiving the messages as required, the signal request message or the signal status message. So there's a lot of detail on the screen here, but that's what it's letting us know, monitor and troubleshooting. So feature of the project, we received an ATC MTD grant couple years ago, supported UDOT to expand its FHWA applications. And so we're adding more snowplow routes. And in the southern part around the Provo-Orem area and further in that Utah County area. Routes will be integrated into the next phase of our connected vehicle ecosystem project currently underway. The system has proved to be quite popular with the drivers. You can imagine not having to stop for red lights is pretty good benefit. But the drivers have reported other benefits, just generally feeling safer. They don't have to worry about stops, sudden stops. They can continue maintain a safe speed, continuous speed. They can plow side by side in platoons and get the left turn lane and the through lanes at the same time, not leaving big piles of snow at the intersection when they stop. Generally more effective, and getting the road clear faster helps the general public. There is some impact when you preempt a signal to the cross streets, but generally the impact is pretty minimal. We're able to recover the coordination cycle within 2 cycles, or about 3 minutes. And the benefits of clearing the snow sooner and getting traffic moving again proved to greatly outweigh the cost of disrupting the coordination patterns. So here's a look at our overall connected vehicle deployments we've been working on. Our connected vehicle ecosystem project is with Panasonic. Up in the top right, the orange dots was the initial ecosystem deployment through Parley's Canyon, Interstate 80 there. We equipped vehicles and the roadside with units to collect data, get insights from vehicle travel patterns. This is related to weather because we could identify when the wipers were on at higher speed or low speed, identify a traction control engaging sudden stops or sudden drops in speed on that corridor. And this processed in the software could give us more insights of weather in the canyon, help the operators back at our traffic operations center know messages to post on the variable message signs. Eventually, we hope to use this information to get information directly back to drivers on an on-screen display in a vehicle, real time to where they're at. So if they've already passed the VMS on the freeway and they're entering the canyon, they can still get real-time warnings about weather and road conditions. The vehicle sensors can also send crash indications back to our traffic operations center. Say if they slip on the ice and crash and the airbag goes off, that airbag deployment sensor can immediately alert the traffic operations center, hey, vehicle's crashed, the airbag went off, we need to dispatch there. Other applications we're working on with this ecosystem are curve speed warning and other applications be developed using the data analytics, sharing the data with other companies. The spot weather impact warning, as I mentioned, is something we're looking at in the canyon. Those orange dots right in the middle there is another canyon road that connects to 2 ski resorts in the Salt Lake area. So click. You can see that S-curve up there. That is that orange arrow right there pointing downward. That is the S-curve in the picture right next to it. So that is could be a treacherous area in the winter if the roads are slick. So the total deployment for this project was 69 roadside units and 35 vehicles in the UDOT fleet. Other additions, other applications, as I mentioned, the transit signal priority, we're expanding the snowplow and emergency vehicle preemption further south there. The green dots, if you see in the lower part of the map, the green dots arranged in a square, that's the city of Orem. We're equipping currently all of the traffic signals in that city. And it will be equipping the city's emergency vehicles with preemption capability, the snowplows and the emergency fire ambulances. And they will be testing the data collection with their fleet vehicles as well to gain more vehicle insight. And further along the corridors to the north, those green dots will be more snowplow corridors. You'll get a signal preemption along those critical routes that were identified by the maintenance region there, where they needed the most help, particularly along the west side of the Utah Lake there and up north, leading into the canyons there. So the total deployment here will be 138 roadside units and 150 onboard units between the buses, plows, and fleet vehicles. Okay, next. And we have future deployments planned here in Salt Lake Valley, that red line running east-west, a corridor requested by the transit agency. And in the upper map, a new bus rapid transit corridor being built right now. These will be able to serve both transit and snowplows connecting these areas. Now, due to frequency changes by the FCC, all of our original deployments in blue dots there were built with DSRC. Our newer corridors being built this year are using cellular V2X and dual mode units. But as DSRC is being phased out over the next 2 years, we will need to replace all those roadside units in blue with cellular. So we'll work around the valley at each maintenance station, update their plows and upgrade the roadside units. Fortunately, the software will largely remain the same. The major expense incurred here was developing the software and integrating and testing the process. At this point is more of just a hardware change to the units. So our snowplow program will continue just with a different technology. Yeah, there you go. See, the next 2 years we'll be replacing DSRC on these corridors. So a look at the effectiveness. We engaged BYU through our UDOT research program to do a research study on the effectiveness of the snowplow preemption. Said here the study is about to be published. I think it went live yesterday, so can't find it. But results, the qualitative results were excellent. That, like I mentioned, the drivers are very happy. They found a lot of benefits to more efficient plowing, more faster clearing the road. The amount of preemptions on the signal were very few. There's typically once per hour during a storm, and if the storm is an hour or two, it would not be a lot of disruption to traffic. But however, trying to compare two roads, one road dry and one road with a storm, or two roads similar, there's so many variables, different types of storms, different amounts of snow. They found statistically comparing one storm to another to be very challenging to get good results. We did see a reduction in crashes and feel like there's general improvement in safety. We'll continue more research, more comparison as this goes on. But in general, drivers, operators, and the department were satisfied with the system so far, and we'll continue with the expansion. So we're welcome to take questions at the end. Thank you.
Yeah, thanks, Peter. That's a good presentation, and I have a whole list of myself just respect the DSRC changes you're having to make. But let's wait till the end, and let's move on now to have Dan give a presentation on the solution he's going to present from Minnesota DOT. Dan.
Thank you, Tony. Will you be the one doing slides, or is that Adam?
Adam is running the slides.
Okay, thanks, Adam. If I forget to say please, then don't tell my mom. But I appreciate you doing the slides. My name is Dan Rowe. I work for the Minnesota Department of Transportation. I'm in the Connected Automated Vehicle Office. I used to be ITS office, but about 3 years ago, they combined, so now we're known as the CAV office. And the project I'm going to discuss is called the MnDOT CAV Traveler Alert System. I came into this project about a year and a half ago. It's been going on for a little over 2 years, I believe. So this project's all about safety, trying to warn people when we have a vehicle ahead of them on the road. Snow plows, guardrail, that kind of thing. Guardrail repair, whoever's out there, we're trying to warn the people as they come up behind them. About 10 years ago, we had a similar project. Iteris is involved in this project, and 10 years ago, they were involved in an earlier version of this project. It was called Wizard. And that went from the Twin Cities metro area to St. Cloud, which is west about 60 miles. And I think it was only on one side of the road. But there we had 14 signs on that project, and it was kind of snowplow ahead, maintenance vehicle, that kind of thing, based on geofence. So this project now is more or less an updated version with more features. Like I mentioned, we're going to warn motorists with a DMS. I know technically, I think it's a CMS. I always use a DMS terminology, but it's 18 by, well, they all vary, but a lot of them are 18 by 6 foot color. So I'll use DMS. And as far as the former Wizard project, I don't know. As a project manager, you kind of just get handed another project and you move on. But that one lasted for a few years, and now we're on the second version. Next slide, please. Adam, can you go to the next slide, please? Oh, I'm sorry. I'm looking at the second slide. I'm looking at a different screen. I got too many monitors over here. Okay, that is the next slide. Yes. Actually, can you back up? Back up to the second slide, please. Yeah, there we go. There we go. That's a nice canned picture that Minda always uses. So we put that on this presentation. But this project is known as a CAV challenge project. And anybody can propose a project as long as it meets the listed goals you'll see with the dark bullets there. The bigger bullets, I don't know if they have to meet them all or some of them, but that is something our office came up with. I'm not part of that review process, but I believe Iteris, I'm almost positive, Iteris proposed this project and it got accepted by those above, and then it got handed down to manage the project. Iteris has been good to work with. Next slide, please. By the way, my slide, I only got like 6 slides, so I'm going to go pretty fast here, but this is, to make sure you have the problem. Well, the problem is pretty obvious. There's so many accidents out there. People are hitting their plows. The safety of the maintenance and snowplow vehicle operators in the traffic public. And in 2018, we had 84 crashes involving snowplows in our state. 2020, we had 72 crashes involving vehicles that hit our snowplows. People get hurt, equipment gets damaged. It's just not a good situation. And that's, we're just referring to wintertime here, and that's a lot more likely for our vehicles to be hit in the winter than it is in the summer. And the contributing factors, I'm sure you all can guess, it's people going into our work zones, because we've got a lot of work zones because we can't work all year round. So whenever the weather permits, we're working out there. Driver distraction, poor driving conditions, snow, ice, that kind of thing. So it's a problem. It is a problem. We're trying to help with this problem by warning people, hey, somebody's ahead of you. And a lot of times you're driving on that road and you see that big white cloud and you don't know what it is. Well, if you're coming up too fast, you're going to run into a plow. So we're trying to solve that with this project. If you could go to the next slide, please, Adam. All right. I don't think this picture's from Minnesota. It just reminds me of the mountains, but I'm using it anyway. So as I mentioned, the objective is to improve the safety, public and employees, MIDOT employees. And we're going to alert the travelers based on a sign. We had the app portion of this project, which I'll get into in a minute. If you could go to the next one, please, Adam. Okay. I'm going to pause for a few seconds here and let you kind of look at that just for a few seconds here. That drawing, you know, this, the AWS, I'm sure, Amazon Web Service. IRIS stands for Intelligent Roadway Information System. IRIS is an advanced traffic management system. I believe MnDOT created this software. Pretty sure about that. And other states use it, I know. But it's used to control field devices, signs, ramp meters, etc., and collect traffic data information. You'll notice that on the left side of this drawing, it deals with signs, and on the right side, it deals with app. We were trying to do an Apple app and an Android app, and those apps were created by Iteris, and we're so close to implementing those. It was decided very recently that we're just going to not do the portion of the app. We had it tested, but there's a lot of questions going around in MnDOT about, is it safe? Is it this? Is it that? So they wanted to do maybe a pooled fund study of some sort. So we're no longer doing the app, but we did have, I think it was like 15 MnDOT supervisors who did try the app and the signs. And the app had a few hiccups, but we never did get the Google people to accept the Android app. We were close, but the language, they kept wanting to change language when they sent it to their Play Store, PlayStation. I can't remember what the term is. But the sign portion worked well. the way it works, I'm trying to look at my notes here. We're monitoring locations of work vehicles with geofencing, terraces, and it sends an alert to the AWS, and that then sends a message to IRIS when the geofence matches the work vehicle location, and of course, also in relation to the DMS. So there's got to be a sign there. It's got to be all the timing built up. You got a geofence area. It's going near a sign. The traveler behind, when that truck is within that geofence, it's going to send that message. We have 138 of these signs broadcasting, and it's mostly freeway. Most of our signs are on the freeway, and they just decided that would be best to do it on the freeway, but it's not in the metro area due to too much activity already going on in that location. So it's pretty much outside the metro area in Minnesota. I'm not familiar. We got some big cities, but the Twin Cities is what we can consider the metro area. So it's places but the metro. And also AVL. The MnDOT trucks, most, if not all, the MnDOT trucks have AVL, but they don't always have it on. And if they don't have it on, this system is not going to work. Why they have it off, I'm not sure all the details on that, but once they have the AVL on, they're going through the geofence by a sign. That sign should light up whether it's winter or summer. The message will say snowplow ahead or maintenance vehicle ahead. I believe it says use caution. The maintenance supervisors who test the system thought it works good. I mean, it tells you there's somebody up there, so be careful. And that's the intent, trying to keep things safe. In the Apple portion, the maintenance people tried the Apple portion of the app, and it worked, but there were some hiccups with it, like every research tech project. If the maintenance yard for certain maintenance shops had trucks happen to have the AVL on and they were parked in the parking lot, it would pick up that information. So it got confusing, but Iteris was looking into it and fixing those issues. But it was just this week when they said, all right, let's just hold off in the app. And that part there, to send a DMS request to IRIS, Iteris is definitely needed for that. We are not able to do that. They know the geofence areas. They're the ones who are working on that. So in the future, if we continue with this, we're going to need somebody to take up that role to help us get it to IRIS and then send the message out. And we're planning on doing pilot testing. We're going to open up to more MnDOT people and some people in the trucking industry and things like that and try it. But because the app, there were some delays, and now we're kind of laying off the app, we're not doing that. And we were going to also release this to the public, but we have a communications office and they got to make sure, it's their job to make sure this app is safe. And a lot of questions came up towards the end here. So it was just decided, let's just continue with the contract with the signs for now, and maybe a pooled fund study or something like that in the future to look into the app. But right now, no app. The project is well received so far from the people who've tried it. They like the project. And we're just going to continue with it. I think our contract goes until the fall, and we'll have to make some decisions before then if we want to continue using these signs. But next slide, please, Adam. I think that might be all I have. Yeah. There's my contact information if you want to talk to me about this project. I'd be happy to answer any questions I can. And with that, thank you for your time.
Thanks, Dan. Appreciate it. Again, if you guys have questions, put them in the question and answer, and we'll bring them back to Dan when we get to the panel session. Just in the interest of moving along quicker so that we have time at the end, I'm going to pass it real quickly to Tyler and let you introduce yourself and your presentation. Thanks, Tyler.
Thanks, Tony. My name is Tyler Weldon. I'm the CDOT State Maintenance Engineer, and I'm here today to talk about the CDOT Autonomous Truck Mounted Attenuator, our ATMA program. We've been working on this program for about 4 years, and we have 2 vehicles in operations currently. Next slide, please. What is an ATMA? It is a truck-mounted, slow-moving attenuator that we use to protect our painting operation. Our painting operation runs about 5 to 10 miles per hour. And I was trying to relate it to weather a little bit, but highway painting is a weather dependent operation. So I think that can connect quite well to this forum. But we're using our protection vehicle to follow our painter. We are taking the driver out of the attenuator truck, and I'll explain a little bit more about how that is done. But importantly, the goals of the program are to remove the driver from the maintenance truck, decrease the risk of the operations by removing that driver, increase efficiency of operations, and pursue cutting edge technology. So we really are hitting all those goals with this project. And that lower picture, you can see what happens when an errant vehicle hits your attenuator. It's quite a mess. Next slide, please. So we're able to take the driver out by using a ECRUM type technology where we're using antennas and vector information as far as speed and direction. It's almost like a tethered operation. It's not truly very autonomous. The driver is out of the system, but it is almost a tethered system. So it's following it close behind. We can spread our gap all the way up to the 1,500 feet if is about our max. But what it does is it allows a DOT to retrofit their existing equipment. So it's actually a kit sold by Kratos to with all the parts and pieces that can connect into your truck. And what it does is it has fingers on the steering wheel, some actuators that control the brake pedals and the accelerator and the steering wheel. So you're able to keep up with that leader truck velocity while you're doing slow moving operations such as painting. Next slide. So currently we're operating in 2 locations in Colorado. Down in the Southwest, we have our most recent deployment in the Alamosa paint crew. And then our first deployment, which is up in Greeley. And I saw that Philip Anderley was on the call. So he's familiar with that part of Colorado. Good to see you on the call. And we're allowed to operate in some of our lower volume roads. The blue roads are 2,500 to 5,000 ADT and so on. And we chose to base our operations on those deployment, not necessarily based on speed limit, but just a lower volume of traffic. And that just allows us to get our program up and going, learn the systems, which is really important, and build that trust of the system. Next slide. Along with the program, in parallel, we started a pool fund, the AMT, Autonomous Maintenance Technology Fund, pool fund. And we have multiple states participating in that. California has done a deployment, Minnesota. Good to see you, Dan, on the call. I'm sure you're familiar with Minnesota's deployment. Missouri has also deployed, and Oklahoma is working on it. And so what we've done is we're trying to pass on our information and our lessons learned from Colorado with the other DOTs across the state to kind of help with the deployment. That's the real focus of this, and worker safety. So it really is a passionate project. We're making a lot of progress, and we're excited to share this information with you. Next slide. So part of the lessons learned is we put together a ATMA toolkit. There's different stages of ATMA deployment, whether that's legislative okay, all the way up to operations. You have to figure out the training, you have to figure out SOPs. There's a lot to it. We meet weekly, Wednesday morning for our Wednesday morning call, and we keep after it. And we just kind of keep the program going. And we meet monthly with the pool fund to share that information. Next slide. So some of the lessons learned from Colorado is really an interdisciplinary approach. We have many divisions involved, whether that's the research division. You get to know your fleet manager. I'm sure you guys with the DRSC signal thing, you'll really get to know your snowplow fleet operators. It's important to have these partnerships. We get to know procurement, trying to buy this technology. So really, it's a DOT team approach with these types of technology. And it's important to have a lead sponsoring DOT division. So Division of Maintenance and Operations was a leader in this. And we're working with the CAVS program as it's matured to work with us with it. And then again, like I said, procurement challenges, buying new technology is always challenging. Some other major lessons learned are managing your expectations. There is a lot of work with these high-tech systems and understanding that there is troubleshooting and that it is a work in progress. And I'm proud to report that, you know, we are making a difference. I talked to the guys from Alamosa just this morning. They're happy the system's working. It is fully integrated and the crews are using it, and it's just becoming part of their equipment. So it's important to have that crew level champion, I would say also. There's a lot of turnover in crews right now, as everyone knows. So it's important to have that one point of contact who can call the vendor and kind of work through the troubleshooting. But it's important to identify that person and really support them. And as things have evolved, we've really tailored the training system to our DOT operations. A lot of times you'll have training from the vendor about the system, but you really need to integrate this into how your DOT does the operations. Next slide. And that was it. That was my 5-minute presentation. For more information, you can contact me at my email below.
Okay, thanks, Tyler. Appreciate it. I actually like driving by those cars where there's nobody in it driving down the road. It freaks me out, but it's really good to see that we're using the technology to do some of those things. And I agree with you that while it didn't completely talk about, you know, it's hard to link that road weather part of it into it. I do believe that weather does have an impact on when you're going to go out and paint and do some of that maintenance. So it is relative to that. Okay, so we have a few questions. I was hoping to open it up to the whole panel and just maybe get a couple of discussions going. So the first one I was going to actually ask Peter, you mentioned in your presentation about that you were going to have to be going out and changing out some of the DSRC communication devices you had, and you're switching to cellular. It's sort of a two-part question. I guess that you're kind of one of the first, I guess, victims of going away from having that spectrum available. And is that one of the reasons why you're moving to cellular versus maybe using the other part of the spectrum that's still available?
Well, we are still using the spectrum that's available. We've converted all the existing ones to channel 180. So we are going to continue using them as long as, you know, the spectrum's on and available, which is still about at least 2 years, I think. And then we'll slowly, you know, as money becomes available. We're budgeting now for conversion. And, you know, as one of the maps, I showed a new route coming online, you know, in the next year or two. That'll be all cellular. So we'll need to convert adjacent routes that the same snowplows will be plowing. We'll need to convert those to cellular too. And it's, you know, those will just be a hardware change, and the system will largely remain the same. So.
Okay, so you might have gone that route regardless of whether or not they discontinued that closed spectrum.
Well, we would have liked to keep using what we have, but yeah, the newer deployments are dual mode, so we, you know, for slim chance the DSRC sticks around, we could use that. But
okay,
once the final nails in the coffin, I guess, you know, we'll convert.
Yeah, that's good to know, because I don't want to think it's completely dead yet, but I'm with you. I'm being careful about what the future is going to hold. But okay, and then a question came in from King Wan Lee about whether or not your connected vehicles were autonomous, and I think I know the answer, but I'll let you answer that.
Ours are autonomous? No.
Right. Yeah, they're just connected, sending the data back, but they're actually driven by a driver.
Right. We still have operators in the snowplows and the buses, and the operators really don't interact much with, like I said, the snowplow operations all happen in the background. There's no activation. They don't even have a monitor to tell them whether, you know, green light's coming on or anything. It's just drive is.
Yeah. And by the way, I assume that's also prioritized for emergency vehicles. Like they have a higher priority preemption than the snowplows. Yeah.
There's a ranking system within the signal controller for,
I
think railroads at the top.
Has there ever been any feedback from the plow drivers of, oh yeah, I noticed I was actually able to get through sooner, or is kind of they
Yeah.
don't know? Oh.
They've noticed that, definitely.
Okay, good. So then the next question is for Dan. The question came up about whether or not when you're sending out that plow ahead messaging, do you do that during the summer? And I don't want to answer for you, but my first response is, actually it could work in the summer too if you had those vehicles out there doing some kind of operations. But is it something you use in the summer or just in the winter?
This is something we plan on using in the summer also. The question I guess I have is, what's it going to say? It's not going to say snowplow ahead because it's summertime. It should say maintenance vehicle ahead. I understand that some areas of Minnesota, it's going to say maintenance vehicle ahead even during the winter, but this project is designed to run year round.
Okay.
Year
Yeah,
round.
I think that's, operations ahead or something like that kind of thing. But makes it a little bit more, I guess, benign, where people at least pay attention to, hey, there's something ahead.
Yeah.
And then the other question came in for you actually was about whether it was hard for users and the public actually to download the app for that, and whether or not you've thought it could be combined with perhaps other mapping messages applications.
Yeah, I'm looking at Brian's questions here. That's a lot of good questions, very good questions, and none of them have clear answers. We had quite the app conversation in a meeting earlier this week, what we want to do with this in the future. There was questions about safety, and it kind of boiled down to people saying, we need to study this more, maybe try to get a pooled fund thing going on with some other states, some other organizations to kind of solve these questions, because I don't really have any clear answers for you, Brian.
Okay.
But I think it's possible what you're suggesting.
Yeah, and I'm just tying into that, I was going to bring in the discussion and sort of, it might be for all of you. I think it was Tyler pointed out that Philip was, the legendary Philip was on the call, and he brought up the point actually that their solution that they've been doing is tying it into some of these other, sources like Waze and other mapping, where their systems automatically send into those solutions rather than just your own solution. Has that been something that you've considered as part of developing out, where it doesn't just go to your own application, but you make it available to other crowdsourced type applications?
Well, we also have our 511 too. Is it, do we want to combine it with that too? Is it kind of a conflict there? A lot of things need to be worked out. So I don't really have a lot of clear direction on where we're going to go with this app idea.
Okay. And then, I guess for Peter, another legend in the community, Paul Bazzano asks whether or not, since we have all the legends here today, ask whether or not you could explain the pros and cons of using a CV-based preemption system versus the more traditional non-CV versions.
Meaning, say, compared to Opticom or
some kind of light thing,
infrared or signal based.
Basically the fire trucks used to use, right?
Right. So we're able to get a lot more tools out of this. So equipping a new city, we've been talking to Orem City, and we're going to, switch over, not just their snow plows, but their emergency vehicles can use the same system. And as I mentioned, there's other insights to be gained from the data collection in the same system using the connected vehicle technology. So not only can you get the signal preemption, you can get the transit priority, you can get the weather insights. We're going to tie into the CAN bus onboard the onboard computer on the vehicles. So get all the windshield wiper data, the traction control, the airbag alerting, worst case, it crashes. So we're able to get all that other data collection in addition to, the signal. Kind of a multi-tool approach instead of a one tool, one application approach. That's the main benefit right there.
Okay. Again, if you have any other questions, please. The question actually came in also for you, Peter, on have you been able to measure how much faster the plowing might be done with these preemption?
Yeah, in the research study, I'm going to post a link here to it. I just found it online here. It was published, I think, yesterday or the day before. But while the speed that travel speeds are limited to 35 miles an hour for the plow, they have on, getting a little bit faster, a little cleaner, faster finish up of their route. Instead of they can't go over that speed, so maybe they're traveling the same speed, but it's more consistent. They're not stopping at a light and dropping a pile of snow there. That was, the benefits they mentioned to us were that, and while the comparison of one route to another isn't exact, we did year to year have a drop in crashes on those routes after we got that. We could see that trend over many years. 1 year to one. 2019 to 20 may not be a perfect example.
Yeah, and plus there's a whole element of the storm severity kind of applying that to it, 1 year versus the next in terms of how bad the weather might have been, how many opportunities there were to use it. So
right, we've had some drought years here, so yeah.
Yeah,
get a new toy and then they're like, when's it gonna snow? Come on.
yeah. So okay, well, hey, we're kind of down to the last 4 minutes, so I think we've answered all the questions. But if you guys have any additional questions, if you go to the next slide, Adam, I think we put the contact information, or at least some links for these guys and their projects. Again, the webinar is being recorded, and so you can always go back and get this information off of the NOCO website if you want that information. The next webinar coming up in September is going to be on road weather management data uses. And as you guys know, and I've been harping on for years, I love the road weather data environment and all of the things that go along with that. So that's going to be the discussion next month. And that'll include some of the things you saw that we came out with the newest version of NTCIP and some of the impacts that'll have on how we get road weather data and how we use it. So be looking for that discussion next month, especially if you're interested in road weather data and how to use it, how to capture it, and how to use it for research and some of those elements of it as well. And then is that the last slide? Again, here's the contact information. So again, if you have more questions or you want to just reach out to these guys and have a discussion, they're all, I'm pretty sure, available and happy to have a discussion with any of you about what they've done and how they're doing it, and some of the gotchas they came across, and some of the things that that might have been challenges as well. So I want to thank everybody for jumping on today, and have a good rest of your week, and we will see you next month on the Spotlight webinar series.
Thank you.
Thank you, Tony.
Thank you.